Alright, welcome back to chemistry. Today we're going to start Unit 8. Unit 8 is about electron configuration and periodic trends. Before we can really start talking about those kinds of things, we got a quick review, atomic structure, and we're also going to talk about the introduction to those electrons and like where they're found and how we label them and stuff like that in the atom. Okay, so we want to look for these key statements and that are going to be the answers to these key questions as we go. Okay, so we want to answer, what is an electron shell? How do we determine how many electrons a shell will hold? How do we figure out how many shells are needed for certain elements with their electrons? And then how do ions and what do ions and noble gases have in common? Okay, quick review. This shouldn't be anything revolutionary for you, but obviously the parts of an atom, we have protons that have a positive charge found in the nucleus. We have neutrons that have a neutral charge that are also found in the nucleus. And then around the outside, they're not actually just sitting there in the cloud, they're actually spinning constantly, are the electrons. And remember, they have a negative charge. And they actually spin because of the attraction and then the energy that they have between that positive and negative. Okay, so there's our first key statement. Okay, another part of our review, we need to talk about how vertical columns are called families. So like over here we have the oxygen family and the fluoride family and so on, fluorine family. But then some of these families have specific names, like in group 1 here, okay, this remember is the alkali metals, and then group 2, this is the alkaline earth metals. Okay, and then we jump to the right side, okay, the very far column on the right, those are the noble gases. Remember, noble gases are special because they do not become ions because they have a completely full outer shell. And then we have our halogens here. They're just on the outside. Remember, halogens, think of them, remember they're reactive because they only need one electron to complete their outer shell. So like fluorine and chloride and chlorine, excuse me, and those elements are reactive because they can steal those electrons and can create some different things from that. In the middle we have our transition metals, okay, and then just inside the transition metals are the inner transition metals. Remember, the lanthanides and actinides. Good. Okay, now each horizontal row on the periodic table is called a period. So we've got period 1, period 2, period 3, 4, 5, 6, and 7. Okay, now what I'd like you to do on your periodic table, okay, starting with period 1, I would like you to go ahead and label period 1 with a K. Okay, and then I want you to continue that straight down. You're going to go K, L, M, N, O, P, and Q. Okay, you're going to label them just like that, and I'll show you why here in a second. Give you a chance to do that. Maybe I'm going to pause it before we go on. Okay? Now, each time we move down a period, and here's another key statement, a new electron shell is added to your atom. Okay? So hydrogen and helium have one electron shell because they're in the first period. Okay? Things that are in the second period, here's my 2 over here, like lithium, beryllium, carbon, neon, they have 2 electron shells. Okay? Again, third period, 3 electron shells. Fourth period, 4 shells. Fifth period, you can kind of see the pattern here. 6, remember 6 includes the lanthanides, and then 7 includes the actinides. Okay, so the most number of electron shells that you can have is 7. Okay, and it gets a little more complicated than that later on, but we'll talk more about that then. Okay, now the number of electrons an electron shell can hold can be determined by the number of elements in that period, and that's kind of a review of what some of the things we learned about early on in the year as well. Okay, so that means the first electron shell can hold 2 electrons. How do I know that? 1, 2 elements in that period, so therefore only 2 electrons are had in that shell. Okay, the next 2 have 8 and 8 elements, so that means they can hold 8 electrons each. Okay, the next 2 then have 18 in each, and then the last 2 have 32 electrons that they can hold. Remember, that includes the inner transition metals, so it wouldn't count straight across. We'd actually include those. And this is actually an older periodic table. We've actually found number 117 here. Okay. So how do we determine the number of electrons in an atom or an ion? We're going to use something called the KLM structure. Okay. And what that means is that hydrogen, since it has 1 electron, okay, that means it's in the first group here, and it's in the K period. Okay, we're going to call that 1 over K, meaning that in the K shell, which is we're going to call the first shell, there's only 1 electron. Okay, so that's what that K refers to, the K orbital. So each time we add 1, we'll move down our letters here. Okay, so that means HE, think about it, would be since it has 2 electrons, now it wouldn't be 1K, it would be 2K. Very good. Okay. The next one, okay, Li. Now, notice it's not in the K. Okay, it's not in the K period, but we can't just jump to that second electron shell. We have to fill the inner shell first. So that means we have 2 electrons in the K orbital, and then we have 1 electron in the L orbital, KL. Okay. What about this one? Give it a shot. See if you can come up with it. Okay. So P. Let me think about this. Okay, it's 15P. So there, what would be the KLM structure? Well, the K and the L are completely filled. How do I know that? Because it's in the third period. So K would be 2, L would be 8. Okay, I know that because that's how many elements are in each of their periods. Now to figure out what M would be, I just count over. Okay, so K, L, M, 1, 2, 3, 4, and 5. There you go. So KLM structure for P would be 2, 8, 5. Okay. Give neon and sodium a try. See if you can figure them out real quick. I'll give you a second to do that. You may want to pause before I hit the button here. So since neon is 10P, that means it would be 2K and 8L. Remember, because the first shell can hold 2, the second shell can hold 8. And then sodium, then, even though it's only 1 away, we still add the M on there because that would be the 1M. Okay, good. Now, what about these ones? We've got our plus ones and minus ones now. Now, what does the plus 1 mean? Does that mean I add an electron? Okay, hopefully you remember when we talked about ions, plus 1 means that we've actually lost an electron and the overall charge of the atom is a plus 1. Okay, so originally, okay, it does have 3 protons. That's true. Okay, that's a 3p, but it only has 2k, meaning that there's only the 2 electrons in the first orbital, and then there's none in that second orbital. Why? Because we lost the 1 here. Same thing for sodium. Sodium normally would go KLM, okay, but since we've lost an electron, we don't need to put the M on there. We subtract that 1. So Na plus 1 is actually, or just Na plus, would be 2K8L. Okay, and then fluorine, same thing. Okay, but this time we've added an electron, so that means this outer shell, even though it only has 9 protons, is completely filled. So 2K8L instead of 7L like it normally would be. Okay, so a quick way to remember how to do this, okay, is that this 9, and then this would be like a plus 1, should equal whatever my KLM structure is. So 2 and 8 equals 10, 9 plus 1 equals 10. Good. Okay, so what do all these ions have in common? Okay, nitrogen 3 minus, oxygen 2 minus, F minus, Na plus, Mg plus 2 plus, and Al 3 plus. Okay, if I subtract these numbers here and add these numbers here to the number of protons that they all have the same KLM structure, 2K8L. Okay, the reason is, okay, that they all are trying to fill that outer shell. They want their outer shell to be completely filled and not have any extra electrons hanging off the edge. Okay. So they all have the same number of electrons as neon, which means they have the same KLM structure as neon. Okay, so atoms lose electrons to fill their outer shell. So everybody wants to be like neon or like a noble gas. Okay, so an electron shell is where the electrons are found. How can we determine how many electrons it'll hold? It's determined by the number of elements in the period. Remember that. How do we determine how many shells are needed? You count down. Okay, if it's in the third period, that means it needs 3 shells. If it's in the fifth period, so in the fifth row down, then it needs 5 shells. And then what do ions and noble gases have in common? Ions want to be like noble gases. Their outer shell should be completely filled. Okay. Now that's the end actually of what we're going to talk about today. We're going to use those KLM structures to do some practice problems. We're going to try to figure out the KLM structures. We'll actually play KLM bingo later on. It's a pretty fun game. But if you want to go a step further, make sure that on the left side of your periodic table you had the KLM structure labeled. But if you want to prepare yourself for next time, make sure you have these numbers labeled on the right side of the periodic table, the 2, 8, 8, 18, 18, 32, 32. That'll help you with the KLM structures. But you may want to also add these letters, S, S and P, S, P, and D, and then S, P, D, and F. And then that'll come in handy later on. Okay, so if you want to go ahead and prepare for that, go ahead and do so. Okay, I see my time's running short. Hopefully you'll learn something. If you have questions, please contact me at jkubuske@gocathedral.com. Visit the website, mrkubuske.wordpress.com. Follow me on Twitter at Coach Kubuske, and otherwise, have a terrific day.